Intrusion detection is an important and difficult task when maintaining a secure computing system. It may not be possible to detect intrusion unless the necessary tools and a well-executed strategy are implemented. If an intruder is not detected properly, we are not able to determine the full extent of the intrusion and damage caused. Moreover, it may be difficult to completely remove the intruder's effect from the compromised system. So for today, consider the network traffic monitoring for compromise detection. The headlines that I consider for this talk is introduction, terminology, indicators of compromise, network traffic logs, and three popular network monitoring tools that are Wireshark, TCP-Dump, and Network Miner. To keep our network secure and running efficiently, we should monitor the traffic of the network based on a regular basis. It helps us to find security vulnerabilities and find compromised systems on the network and do something about them before they cause damage. But what is a compromised system? Compromise is a nice way of saying that someone or something has maliciously broken into the system without permission, and it can expose confidential data to unauthorized people. Indicators of compromise is an artifact observed on a network that with high confidence we can say that a computer intrusion and potential malicious activity is done. Let's have a talk of several indicators of compromise. Here I want to talk about 12 indicators. The first one is unusual outbound network traffic and suspicious destination IPs and domains. It can be a sign of potential threat when unusual traffic leaving your network. Don't think that only ingoing traffic is important and inside network traffic is secure. Always have a look for suspicious traffic leaving your network. You cannot make sure that you always can keep attacker out of your network in modern networks, so watch for activity within the network. Check where are destinations of outbound traffic. Check for domains or IP addresses that are unfamiliar and can be anomalous destination, and also check if they are on blacklists. Outgoing traffic can be forwarded to your SIEM solution. SIEM is Security Information and Event Management Device, and automatically their destination, the IP address and domain, can be validated by the SIEM. Some SIEM solution can come with services such as a domain blacklist checking. The second indicator of compromise is unusual DNS requests. These requests are from network clients to external servers. Sometimes attackers change DNS settings to compromise the system. In this way, they can redirect the traffic to their own servers and so control the compromised system communications. They can redirect the user to malicious sites. This method is powerful, yet simple to establish a permanent foothold on a machine. Check outgoing DNS traffic. You should always see an internal DNS server IP address because clients don't usually send DNS queries directly to a DNS server on the internet. For example, in a Windows environment running Active Directory, workstations that are part of a domain need DNS to point to domain controllers that host DNS services to RSD, ND, and authenticate to the domain, and then to ND and address on the internet. Because workstation point to domain controllers, the normal DNS traffic to the internet should originate from the internal DNS server. Any DNS query from a specific host to external host can serve as a potential indicator that the host DNS setting have been hijacked. So watching for DNS requests and implementing appropriate filtering are good network security practice. The third indicators that we talk about is anomalies in user account activity. Sometimes you can see some changes in behavior of privileged user account, and it can be a sign that account is compromised. So, watch some changes such as time of activity, systems accessed, type or volume of information accessed can provide indication of a breach. Unrecognized protocols. The next indicators, unrecognized protocols or unrecognized ports. In network communicates, well-known ports identifies the application and protocols which is used for the traffic on that port. Usually malware use unknown ports. Analyzes the traffic that originates from unknown ports or non-allowed ports can give you some clue about the potential threat. As your information allowed ports and non-allowed ports determined by setting of your firewall rules. So analyzing the traffic which isn't allowed can show that a compromised machine attempts to communicate, and it can help to identify compromised systems even when those attempts are unsuccessful. Masquerading known protocols. Sometimes malware hijacks a known protocol's port because traffic which is associated with a known port and application is allowed through a firewall and can be sent externally. Be careful that there is no guarantee that the data that is sent over that port is actually innocent and no need to examine. If embedded malware communicates to a server on well-known ports, then the malware will be successful in its attempt. To identify this type of threats, look the assumed purpose for the port and analyze to the application protocol to determine whether it matches the structure of traffic that is expected for a given combination of protocol, port, and application. Keep in mind that you cannot always, a protocol such as HTTPS will run only on port 443. You can establish web browsing sessions over any port, so you also cannot assume that port 443 traffic is always HTTPS or web browsing traffic. Many remote session vendors communicate over port 443 to avoid requiring special firewall rules to function. Prohibited protocols. There are some protocols such as SMTP, Simple Message Traffic Protocol, SSH, Secure Shell, VPN, Virtual Private Network, and IRC that is used for instant messaging. These protocols may be used in network but are not allowed to use by some hosts. Analyzing the use of prohibited protocols by hosts can help to indicate threat traffic. To do this, you must address two issues. The first is which host should or normally do to communicate using the given protocols. The second issue is how much traffic is normal over a given protocol. Baseline the bandwidth use of each protocol's traffic and set up alert for when traffic amounts fall outside those established norms. Geographical irregularities. Geographical irregularities and connection to countries that company or organization does not communicate and does not do business can provide good evidence that attackers are pulling some things from far away and offers reason for pause. Similarly, when one account logs in within a short period of time from different IPs around the world, that's a good indication of trouble. The other indicators is HTML response size. Sometimes considering the size of HTML response can reveal an attack. For example, in a SQL injection attack, if the attacker tries to extract a full credit card database through a web application, then a single response for that attacker might be 30 to 60 megabytes, where a normal response is only 250 kilobytes. As you can see in the slide, the next indicators of compromise is a lot of database threat. Once an attacker gets through the system, he seeks for information, so there will be a large amount of read operation from key databases. For example, attacker tries for getting full credit card information from the credit card data tables, and it will generate a more high volume of read on the credit card tables than normal situation. Registry or system file suspicious changes also can be indicators of compromise. Changes in registry and file system always are important. It can show something in our system is happened. It's also true when we are talking about compromising. Attackers often will install sniffers to monitor network traffic and collect valuable information such as credit card or user credentials or identification as data pass through the network. Installing hardware and software create changes in registry and system file. So be careful of these changes. Unusual number of failed login. It can be an indication that someone is trying penetrate and access our network, especially using user accounts that doesn't exist. These often indicate someone is trying to guess a user's account credentials. The last indicator that we have here is a lot of requests for a file from the same IP. You know when an attacker wants to get inside our site or just compromise a site, needs a lot of action to do and also a lot of exploit tries to find something that works for him. So if you see a lot of requests for the same file from a single IP address, it can be a sign of compromise. We did review several indicators of compromise. Now let's see how we can find them. Key indicators of a compromise can be found by analyzing the network traffic from outbound connections, specifically traffic coming from an endpoint on your network and connecting through your firewall to somewhere on the internet. Now we want to monitor the traffic, but there are two important things we should consider. The first one is choose the right data source. For monitoring network traffic, you have two main data sources, flow data and packet data. Flow data can be acquired from like 3 devices like routers, and it's not very good for detection of compromised system because just it can give some information about the volume of traffic and source and destination IP address the traffic. Sometimes you want to work something about the performance of network. It is good source of data. But when you are dealing with detection of compromised system, the packet data can give you the details, and the packet data can be sourced from port monitoring or via taps. And what is port mirroring? Port mirroring, that also known as SPAN, that SPAN stands for Switch Port Analyzer, is a method of monitoring network traffic. Here, have a look at the picture. You can see we have a switch and two ports are presented by a yellow color of arrows. These two ports are our source span ports. That means we are interested to study the traffic that is passing through these ports. And we ask the switch, by implementing the span or port mirroring, we ask the switch to send a copy of all traffic passing these ports to send the port that we set as destination span port. So we can install a sniffer at destination port and monitor and analyze all traffic. So the number of source span ports that we are interested to study the traffic of them can be more than 2. The other things that we choose carefully is the correct points on the network that we are interested to monitor the traffic. Points where data converges are good points to monitor the traffic. They are gateways, Ethernet ports on WAN routers, or VLANs that are associated with critical servers. Here I have a picture that shows a network. You can see a core switch here in the picture that all server like file server, database server, application server, and intranet server are connected to this core switch. So the traffic of servers are passing this switch. And we copy all data from these ports and send it to a port that is shown with the red color and called monitoring port. The monitoring port is the other name for destination span port. And then all of them copy in this port, and this port is monitoring by a hardware monitoring tools. The other things that I'm interested to talk about is about network traffic and traffic logs. If the security person looking for a lot of details, the firewall may be the right place he go from a network logging perspective. Because devices like switch and routers don't usually like user level information, but you can get a lot of logs, a lot of information from the firewall. Another security device that can give you more logs is intrusion detection or prevention system, IDS or IPS. It logs unusual traffic pattern or traffic that happen to match a particular signature. It means you determine some particular signature, you find traffic that match with that or those signatures, it log that. Okay, let's talk about tools for network traffic monitoring. There are a lot of tools for traffic monitoring. You can see some of logos here: TCP DOM, Network Miner, Metasploit, and Wireshark, Snort. But here we want to review 3 popular monitoring tools. The most popular and the powerful tools for monitoring and analyzing the packets is Wireshark, that is a free and open source tool. It is used for network troubleshooting, analysis, software and communication protocol development, and education. Education means that you can, in details, study how protocol works. But network security engineers use it to examine security problems. Wireshark, originally named Ethereal, the project was renamed Wireshark in May 2006 due to trademark issues. Now let's talk about Wireshark features. Wireshark is available for Unix and Windows. As I said, free and open source. It can capture live packet data from a network interface and save packet capture. Display packets with very detailed protocol information. It can export some or all packets in a number of capture file formats. It can import files from other packet capture programs and tools as well as from text files that containing hex dump of packet data. Hex dumps means that from the file that include the hexadecimal presentation of data. Wireshark can create various statistics, very interesting statistics, and you can filter the output based on different criteria like protocol, like IP address, source IP address, destination IP address. So your output will be very clean, not a bunch of information. And also you can do your search over packets based on these criteria. Here is an output of Wireshark. You can see it can give you a lot of details. You can see in picture that we have time and a source IP address, destination IP address. It also shows the port number for source and destination. And the protocol that is used for traffic, a lot of information about the traffic, the layer 4 that is used for the traffic. If it is TCP, it can show the flags of the TCP and also the UDP. And here you can see the bottom. You have a part that shows the hexadecimal presentation of data, and at the right of that, it shows the ASCII code. So if you have any text in the data, you can see here if it is not encrypted. Now here I have something interesting for you. It shows a malicious traffic that is infected by TrickBot Trojan. TrickBot is a Trojan that it gets on a computer, and it can come through something such as an email attachment or a PDF document. What is inside the system, it will most likely download other malware. And usually TrickBot send a TrickBot malware binary through SMB, that is a protocol for message sending in a network, and spread from client to domain controller. So here you can see we have infected Windows client at the address 172.168.4.119, and this is the infected host or client, and it will infect the domain controller at the address 172.168.4.1.4, and you can see here these addresses, and there is a host here that is malicious destination 185.171.232. This is the server of bad guys that include the warming.png, the malicious file, and the client is infected by this, and then the domain controller also will be infected by this file. So now here in this picture, I want to talk about a feature, powerful feature of Wireshark. It's very hard to study packet by packet, correct? So if you right click and the traffic, and then there is an option that is follow TCP stream. And if you click that, the information can be presented in a simpler way. So you will have something like this. The red color is for information that is sent through the client, and the blue is for the information or the data that is sent by server. Here is, we can find this text in the output HTTP 185.171.232 warming PNG. Yes, it is the URL for TrickBot that is sent from client to the domain controller, our SMB, and then the controller will be infected by this. So you can find the trail of malware. Now let's talk about the other popular tools, that is TCP dump. TCP dump is a packet analyzer tool that runs on a command line interface, and it's a Linux utility. It allows the user to display TCP IP and other packets that are transmitted or received over a network. TCP/Dump is a free software distributed under the BSD license. It comes bundled with most modern Linux distributions. Here is an example. This example is for capturing a specific number of packets from a specific interface. So here you can see we type TCP/DOM-C12-I ENP0S3. ENP0S3 is the name of NIC card, network interface card. So we are interested to capture the traffic that is passing from this network card. And 12 is the number of packets that we want to capture. So here you can see the output, a screenshot of the output. Here the packets that are captured are presented with green color, and 1, 2, 3, 4 packets are captured. The last tool that I want to talk about is Network Miner. Network Miner prompting itself as a forensic network analysis tool for Windows, and it can run in other operating systems now. An open source tool that can analyze a network passively and comes with an impressive GUI interface. It explores contents of previously captured data packets in a PCAP format. It means that it can just open the other files that are obtained from different tools, and they are in PCAP format. And also it's a tool for hacker because it can detect operating system host names and open ports of devices of the network. Here is a picture, a screenshot of output of Network Miner. As you can see, there are a lot of details about the traffic, source address, source port, destination IP address, and destination port, the protocol, now file name, size, and the other information. So we talk about network monitoring and network monitoring tools. Now, as a conclusion, I want to say that regardless of the size of a network, it needs to be protected and needs to be monitored regularly. By monitoring network on a regular basis, it would be much easier to identify anomaly network traffic and a potential intrusion or potential attack to the network before any damage is done.